Hello, everyone. Welcome back to Python Challenge for All. Okay, so last time we solved a very simple equation to find the square root of 5. Yeah, by solving x squared minus 5 equals 0 using two methods we um, found the value of square root of 5 and also visualize and compare the difference of convergence in two methods. Okay, so okay, let's try, for example, to try to solve another type of equations, which is algebraically unsolvable equation. Interesting. Yeah, let's think about x cubed equals cosine x. Okay. Uh, I don't think you can solve it algebraically. Okay, right? So we can only solve it by numerical methods. This is transcendental, transcendental equation. So no closed form algebraic solution exist. Okay, so let's try it. So first, yeah, you can try it yourself. Stop the video and try yourself to solve it. Okay, I hope you um, came back with your answer. So let's check that. So first thing to do is visualize the difference. So here we can define f of x as x cubed minus cosine x. Okay, so let's go ahead with it. So just like last time, we, yeah, we can copy this part and all the way down here and paste it here and change this as what? Uh, X cubed minus cosine x. So cosine x can be defined as math dot cos times x. Okay, here maybe we might want to make sure that we import math package. So let's see how it looks like. Is this range okay? 0 to positive 5. Okay, let's see how it looks like. Very simple. But here we have some intersection here. Of course, you you know x cubed graph. You know what x cubed looks like. And also, just in case, let's delete it and see how cosine x looks like. So cosine x is like this. Okay, here is half of pi, so 1.7 something. There's an intersection here and here one intersection here. Okay, so anyway, if you subtract it from x cubed, this is much stronger, so it's not so visible. But if you use ylim, plt ylim to 0 to say 2, 0 to 2, maybe we have, we can easily see. Yeah, okay. Let's change this to 2. Okay, to see how it looks like. Okay. Not so good. -1 to 1. Maybe we can. This, okay, sure. Yeah, right. So here's some intersection here. So it should be 0.7 something. So we will try to solve this. Okay, so what to do is just the same. So we will copy these boxes and paste it here. Copy and paste it here. And we change here. So starting is maybe just the same. For bisection method, it's the it goes the 0, f of 0 is negative and f of 5 is positive. So you can just use it, the same method. So let's try it to see have the same delta value. Okay, it terminates in 20 rounds. And the answer is like this, 0.86 something. Okay, let's try. No, this is not. So let's try again Newton-Raphson method for the same thing. Maybe the x starting is the same as 5, and we will do the same thing. This is not so good. What's wrong with it? Out of range. Let's see what's wrong with it. Of course, we have to modify here. Okay, let's go back to the slide and see what we need to do. So for in the bisection method, it's the same. But in Newton's method, of course, we should calculate the f prime, the derivative of x. So if you differentiate this, 3x squared plus sine x. So we have to have the equation. Yeah, the assignment is like this. So we have to change that. 3x squared. So we have to change here. Okay. So instead of 2 times x, we need to 3 times x squared, maybe here, plus math dot sine x. Okay, so this 3x squared 3 plus sine x should be subtracted. Yeah, y over this one should be subtracted from x. So okay, this should be the correct iteration. So we will have the answer in 7 steps. Okay, fine. 0.865, 0.x5, x65. Okay, the same. Again, just like last time, we will compare the speed by running the same code. Okay, let's run it. So here, okay, the convergence for Newton-Raphson is a little slower, but the same. The tendency is the same. Bisection method goes straight down like this, while Newton-Raphson very steeply decreases the error and reaches the tolerance very fast here. As you can see, it stops in 6 or 7 rounds. Very good. So this is how we now checked that the bisection method and Newton method give the same answer, and now we compare the convergence speed by plotting the graphs and visualizing the convergence. Okay, we used the logarithmic scale for y, which makes the visualization much more easier to understand. Okay, so I hope you like this. And that's all for today. Please come back again next time. Bye bye.